Hello everybody, welcome back to Unit 4 where we are exploring probability distributions. And today we are talking about transforming and combining random variables. This is lesson number 6. Our essential question only touches on the basic topics that we're going to be working on today. How does combining two random variables change the center spread and shape of the probability distribution? But it does summarize everything. So, some of the more specific goals that we have for today's lesson is to understand when and why we're going to be transforming random variables and see how we can change that context, and also to see the kinds of questions we can answer when we want to transform and combine random variables. Now, this seems like a really arbitrary explanation to go through all this lesson without some context, so let's add some context by actually going through and looking at the examples first. Our first example, El Dorado College, or as the hip kids call it, the EDC, considers a student to be full-time if he or she is taking between 12 and 18 units. Now, the number of units, X, that a randomly selected El Dorado College full-time student is taking in the fall semester has the following distribution. So as you can see, this is a discrete random variable because there are gaps between each of the different units that somebody could take. And when we're talking about working with discrete random variables, then we want to think about, okay, maybe I can make a histogram of this, and I can use that sigma pixie formula to find the mean. I can also use an online calculator in order to find the mean and standard deviation, or the expected value. So let's take a look at our first question and see if we can't answer it just intuitively. We want to calculate first the mean and standard deviation of the number of units a full-time student is taking. Well, number of units is our variable that we are calling X. So that means we are looking at the mean of X, which is the same thing as the expected value. Now, we could do sigma pixie for all of this, right? We could say 12 times 0.25, 13 times 0.1, so on and so forth, and add them all up. Or we can simply use an online calculator. Let's go ahead and do that. All right, so I have the entirety of my probability distribution input into my calculator. Press the calculate button and we can see our standard deviation. If I round it to 2 decimal places, will be 2.06. The mean, as the first thing that I was looking for, was 14.65. So let's go ahead and write out those values. We have answered our first question of the day. So that's 14.65 units. And then the standard deviation of the number of units was 2.06 units. Now, our next question, at the EDC, tuition for full-time students is $50 per unit. That is, if T is tuition charge for a randomly selected full-time student, then T equals 50X. We're going to calculate the mean and standard deviation of the tuition for a full-time student. So it seems like we're doing the same thing, but now you can see that we are actually looking to calculate the mean and standard deviation for not the number of units, but for tuition. So we're changing the context of this random variable. How do we handle that? Let's go back up to our notes and take a look. So when we're transforming random variables, the idea is that we want to look at a distribution through a different lens, different context, different units. That might mean unit conversion going from inches to centimeters, pounds to kilograms, or in a case like this, we're going from units to dollars. And this can also be utilized in a business sense. If you're selling something, how much are you selling it for in each instance? Okay, and with a different probability distribution where each number of units sold or each number of units taken by a student varies with its probability and that outcome, then that becomes a little bit more complicated. But the good thing is we can actually find a very quick shortcut for this, because when you are multiplying or dividing by a distribution by some value, it's going to change your summary statistics. The same thing with adding or subtracting. What do we mean by summary statistics? We mean the center, which is your mean or your median, your spread, which is your variation measurements like standard deviation, IQR, and range. But the shape doesn't change. And why that's important is because the shape is like the overall nature of the distribution. So we're manipulating the distribution, but we're not changing its overall nature, and that's really important. Now, here's what we can see with this. Multiplying changes the center and the spread. So we want to make an extra clear note of that. Multiplication or division changes center and spread. Okay? And the way that we work with that is very simple. Whatever that changing factor is, we just multiply that by the mean to get our new mean. We just multiply that changing factor by the standard deviation, and that gives us a new standard deviation. So let's go ahead and answer that question now. if we want to find this, we have to take a look and see what kind of operation it is that we are performing here. Well, 50x is 50 times x, which means that's multiplication. And we know that an operation that is multiplication, changing every single value, changing these number of units, that's going to change both the center and spread. Now, I could multiply each of these by 50, but that's too time consuming, right? What we found is that if we wanted to find the mean for tuition, mu sub t, we just take 50 times the mean number of units. Same thing for the standard deviation of t. The standard deviation of the tuition will just be 50 times standard deviation of units. So 50 times 14.65, when we plug that into a calculator, is going to give us $732.50. Notice I included my new units. I'm showing that transformation to give myself some context here. And then 50 times that standard deviation of 50 times 2.06 units, that's going to be $103. Now, there's one more question that I want to add to this, okay? And that's something that I like to coin as the typical range. This is not something that is usually assessed on the AP tests. It's not something you find generally in textbooks, but I think it's a good way to get an idea for why mean and standard deviation are related to each other and why we care. So to calculate that typical range, we're just saying, well, what's one standard deviation within the mean? Mu plus or minus sigma. So all we do here is say, I want to know what is 732.50 plus 103 and 732.50 minus 103 to give me that typical range. And that's $629.50 when I do that subtraction. And when I do the addition, that's $835.50. Now, what does this tell me? This typical range is actually a little bit more important than just the average to me, because I know that any one student is going to vary from the next. And while I might have a good idea based on the average, I want to give myself a little bit of wiggle room. Right? That mean is the best guess I could have for how much I would expect a student to pay in tuition. But I know I want a little bit on either side to give me some cushion. So this allows me to see if I can tell that a student is paying more than $835.50, then they are paying an atypically high amount in tuition. If a student is paying less than $629.50, that means they're paying an atypically low amount in tuition. And so if I can start to see that this is changing, I'm starting to see more students that are making above this threshold or below that threshold, then maybe my thresholds need to change. And the patterns are changing, the trends are changing. So very powerful tool to think about this typical range and helps us understand why we care about that standard deviation. Now, the next question. In addition to tuition charges, a student at the EDC is also assessed student fees of $100 per semester. If C is the overall cost for a randomly selected full-time student, then C is equal to 100 plus T. Now we want to calculate the mean and standard deviation for the overall cost. So now we're looking at what's mu sub C and what's sigma sub C. Well, how do we handle addition, right? Because that's the operation that I see here. Is it the same? Does it affect both center and spread? Looking back at our notes, I can see that no, it doesn't. It's going to change the center only. So we can add or subtract the change to that mean to get the new one, but the standard deviation does not change at all. And this should make sense because standard deviation is really looking at the difference between one student and the next. And if every student is assessed the same $100 fee, it doesn't matter how many credits they're taking, they're still going to be having that additional $100. So their variation is not dependent on this $100 fee, it's dependent on the number of units they take. So our standard deviation will not change from the tuition that we had. So the standard deviation is still going to be that same $103. Now the average amount is going to change because everybody's getting that, so the new average also went up by $100. So we take that $732.50 and we add the $100 student fee to it to give us $832.50. So now we get a new typical range for how much the overall cost is for any randomly selected student. Adding 100 to each one of these values, or taking that 103 subtracted from $832.50, and we are going to see $729.50 or $835.50 for our upper boundaries. Okay? Now, let's take a look at our next question. We got a new probability distribution. So the EDC also has a downtown campus specializing in just a few fields of study. But full-time students at the downtown campus take only 3 unit classes. Let Y be the number of units taken in the fall semester by a randomly selected full-time student at the downtown campus. Here's the distribution. Well, we're already given some of these calculations. We're given the mean for downtown. We're given the variance. That's interesting. We haven't seen variance yet. And we're given standard deviation. So our first question, if you were to randomly select one full-time student from the main campus and one full-time student from the downtown campus, what would be their combined mean units and standard deviation? Well, how can I just add any two randomly selected students? How do I know one student is going to be getting 12 and another student is going to be getting 18? Or vice versa. It's all dependent on their probability too. Those are all likely to change. So what do? Well, let's go back and look at combining random variables. So in order to combine random variables, the reason we do this is because we want to examine two related but different random variables together. And the way we do that is we can combine their means and standard deviations as well. Combining means is super duper simple. All we have to do is add or subtract the means based on the language of the situation. So you have to see, are you combining to find the sum, or are you subtracting to find the difference between these two? Looking at our example, we are trying to combine to find the total number of units that they would take. So mu sub x plus y will be two randomly selected, one from X, the main campus, one from Y, the downtown campus. Adding those two together, we had 14.65 was our mean from the main, 15 is our mean from the downtown, and that gives me 29.65 units. So we're halfway there. Now, what about standard deviation? Let's check our notes and see if we're just able to add or subtract those. Is it that simple? And the answer is unfortunately no. We have to go through a 3-step process, and that is to square them, add them, square root them. Why? Well, let's think about standard deviation. Now, this is not the standard deviation for discrete random variables formula, but it is going to illustrate in a very reductive way why we have to do it the way we do. So this is the formula for standard deviation and any other distribution. It's taking the square root of the difference between each individual value and its mean, looking at that average difference. Okay, but we have to take the square root of it. And so let's think about this for a second. If we had square root of 3 and square root of 2, does that give us square root of 5? And the answer is no. We can't just add those two values together. That's not how the addition with radicals works. Okay? The radicands have to be the same number in order for them to work. So we can't do that, right? So what do we actually do? Well, what we need to think about is, how can I start to add these numbers? We need to get rid of that square root. Well, how do I get rid of square root? The inverse operation of square rooting is to square it. So if we square it, the square and the square root go away, and now I don't have that square root problem anymore. And the same thing has to happen on the other side. So we square the left-hand side and we're left with sigma squared. Why do we care about sigma squared? That is the variance. So in the last lecture, we talked about the variance a little bit, but we said, it's not super useful as far as an interpretive value, but we do use it in calculations later on. Well, here it is. What we have to do is we have to take those standard deviations, convert them to something we can work with, and that's the variance. Once we convert it to variance, then we can combine them. That's doing the addition. And then we have to turn it back into a standard deviation by taking the square root. Hence, what we do, we start with our standard deviations, we square them, we add them, and we square root them. In other words, add the variances together, then take the square root. Either way you want to look at it doesn't matter. But that is going to help us to combine standard deviations. Now, this rule only works for independent random variables. If they are not independent random variables, then we have to do something else entirely, and that's beyond the scope of this course. Okay? But to find the sum or difference of two variances, we can add them both. So for adding, we add, and subtraction, we add. You might think, wait a second, hold on. That's got to be a typo, right? For subtraction, we add. The answer is no, that is not a typo. For subtraction, we do indeed add. Why not subtraction? Think about what we're doing here. We are introducing a second variable. If we are introducing a new variable, then what are we doing with the variation? The root at the word of variable is variation. That means that whether we are subtracting, finding the difference, or we are adding, combining standard deviations, we are increasing the amount of possible variation. Okay? No matter what you're doing, addition or subtraction, you're always increasing the variation. So, no matter what you do, if you are adding or subtracting your standard deviations, you are still going to be squaring, adding, and square rooting. Let's put it into practice. So to find sigma sub x plus y, we will take each standard deviation. So the main campus standard deviation was 2.06. The satellite campus, or the downtown campus, was 2.30. We square them. We add them. We take the square root. Okay, now go to some calculator like Desmos. A graphing calculator is really helpful. Your basic scientific calculators are a little bit more difficult to work with here, but this can be a lot easier. So the first thing you want to do is take the square root. Then we have 2.06 squared plus 2.30 squared. And you'll see 3.09, that's our standard deviation for the combined units, or combined student units. And there's our standard deviation. Now, our next question, how many more units on average would you expect a randomly selected main campus student to take than a downtown campus student to take? Well, here's what I see. How many more units? To me, that says we're looking at the average difference. What's the difference on average between these two campus students? Difference is subtraction. Now, means can be subtracted. That's completely fine. But it does say how many more does the main campus student take compared to the downtown campus student. So that's taking the mean from the main minus the downtown. And that gives me negative 0.35. Wait, I got a negative average? How does that make sense? All that's really telling you is that downtown students are actually taking more classes or more units on average. Now, our last question that we want to consider today. What is a typical range for the amount of tuition two randomly selected students, one from each campus, at the EDC would expect to pay? Okay, that's what we want to try and find out now. So this is incorporating transformations as well as combinations. How do we do it? This can get a little bit tricky and a little bit tiresome. First, think about that idea of typical range means I want to add or subtract the standard deviation from the mean. Okay, so we need to find out, well, what's the mean? And we're talking about tuition here. So what's first off the mean tuition for one student from each campus? And we actually found that already, right? We can do let's do our transformation first and then combine them. And that's going to be 14.65 units times $50 per unit plus 15 units times 50 units. Now, since it's the same factor here, or same multiplication value, because it's the same tuition for each campus, we could put these together and do one combination, and that wouldn't be that big of a deal. However, when we punch this into a calculator, we should get $1,432.50. So next we need to calculate the combined standard deviation. So to combine these two, we are adding them together, and we remember that our process is to square, add, square root. The problem is I don't have the transformed into tuition yet for both of these. I do know that this one, the sigma of t from the main campus, the tuition, that was $103. We already did that transformation. But the second one that we need to do, that's the standard deviation we have was 2.3, and we need to multiply that by our tuition cost, $50, and that's going to give us $115. So now, to square, add, and square root these, And that's going to give us $154.38 after you punch that into a calculator. Now that we have that, we can go ahead and find our typical range. So remember the typical range, we are just going to do the mean plus or minus the standard deviation. So that's the $1,432.50 we calculated in this first part. And we're going to add and subtract that with the standard deviation we found in our second part, 154.38. And when we subtract first, we get a lower bound of $1,278.12. We get an upper bound of $1,586.88. And that's going to give us our typical range. So with that typical range, you should be able to now understand and interpret this is what we would expect to see from any two randomly selected students. But if we have students that are outside of this range, we would say they're a little bit weird. Okay, and that's a really good tool for us to use in statistics, is to see what's usual and what's unusual. What do we expect to see and what do we not expect to see? That becomes huge when we get into our next unit that talks about inference. So take these skills, put them into practice on your assignments, and I'll see you next time. Thanks for watching.